Our next limiting reactant problem says at STP, what volume of laughing gas, and it gives us that laughing gas is dinitrogen monoxide, will be produced from the reaction of 40 liters of nitrogen gas and 75 grams of oxygen gas, and then how much excess reactant will remain. So once again, we're going to start by writing our balanced chemical equation. So dinitrogen monoxide is being produced, so that's our product. So dinitrogen into O is being produced from the reaction of 40 liters of nitrogen gas, so that's into and 75 grams of oxygen gas, so O2. So N2 plus O2 gives us into O. Okay, so now we have our reaction. I'm going to actually move this over just a little bit so we have this all together. We do need to balance our reaction. So we have 2 nitrogens on each side, but we only have 1 oxygen on the product side, and I didn't really leave a good space to write my coefficients, so I'll change that now. So I'm going to put a 2 in front of N2O on the product side to fix my oxygen, and now of course I'm also going to have to put a 2 on the reactant side. And I'm also going to put a 1 in front of O2 just to remind myself that the coefficient on that is in fact a 1. And so we'll make that just a little bit smaller. So there is our balanced chemical equation. So now we need to figure out how much N2O can be made from the 40 liters of nitrogen gas and the 75 grams of oxygen gas. So I want to convert them both into the same unit of N2O. So I'm going to start out by converting them both to moles. So we'll start with both values, so 40.0 liters of N2. And so we will go from liters of N2 to moles of N2. And then from moles of N2 to moles of our new substance, moles of N2O. We want to know how much laughing gas can be made. And we'll get that answer in a second. And then our other given value, other than the 40 liters of nitrogen gas, is the 75 grams of oxygen gas. So we'll start with 75.0 grams of O2. And we will go from grams of O2 to moles of O2. And then from moles of O2 to moles of our laughing gas, our N2O. And so now, once we get our answers, we'll be able to compare the amounts of N2O that are produced by each of these reactant amounts, and then identify the limiting reactant and therefore the theoretical yield. Okay, so let's fill in some numbers. I know that 1 mole always equals 22.4 liters of gas, and we have nitrogen gas, so that works out. And then I'll look at my chemical equation for my mole-to-mole ratio here. N2O I can put a 2 next to, and N2 I can also put a 2 next to. So it's a 2-to-2 ratio here. Then for oxygen, I know that 1 mole of oxygen gas is going to equal oxygen's mass times 2, so 16 grams times 2 for O2, so that would be 32 grams per mole. And then for N2O, we still have a 2 next to it in the chemical equation. And for O2, we actually have a 1 next to it in the chemical equation, so it is a 2-to-1 mole ratio. So now we just need to multiply and divide this out. So let's see. So 40 divided by 22.4, and then times 2 divided by 2, which we don't need to type into a calculator. So when I typed this in, I got 1.7857. Notice I'm not really rounding my answers here because these are still intermediate values. It asks for volume of laughing gas, so I'm going to have to convert my amount of theoretical yield from moles into liters again. So this is my moles of N2O. And then on my oxygen, I do 75 divided by 32 times 2, and I got 4.6875 moles of N2O. Okay, and so right away we can see that the nitrogen produced far less than the oxygen did, and so our limiting reactant would be the nitrogen. And so we'll go ahead and label that. Our N2 is our limiting reactant because it produced less moles, so this is not going to be our theoretical yield. This value up here is going to be our theoretical yield, but of course we still need to convert that to liters. And since N2 is limiting reactant, that means that the oxygen is available in excess. We're going to have an excess of oxygen here. So next we'll just convert our theoretical yield into the desired unit. So instead of moles of N2O, we want liters of N2O. And I know that 1 mole is equal to 22.4 liters. So when I do 1.7857 times 22.4, let's see. Let's see. I'm having a hard time finding my calculator. Here we go. 1.7857 times 22.4 gives me 40.0000, all the zeros on that 40, so that I can round easily to 3 significant figures, which is what I started with. So 40.0 liters of N2O. Now, you might be saying, oh, we got the exact same value. And that does in fact make sense, because for every 2 moles of N2 that we put in, we get out 2 moles of N2O. And since we know that any gas fills the same volume, if we get out exactly the same amount of N2O as we put in, the same number of moles, then we're also going to have the same volume that we put in. But in reality, there actually is more volume because the oxygen also takes up space here. Okay, so now that we have our theoretical yield and our desired unit, I'm going to go ahead and box that in and label this as the theoretical yield. Okay, and then all we need to do is figure out how much excess remains. So we know that we used some of our oxygen, but not all of our oxygen. So to figure out how much got used, I'm going to start out with my moles, my theoretical yield in moles. So I'm going to start out with the 1.7857 moles of N2O. And I'm going to convert that back and figure out how many grams of oxygen got used up with that. So moles of N2O, 2 moles of O2, and then we'll convert our moles of O2 to grams of O2. And the conversion factors are easy to fill in. Our mole to mole step, we look at our equation. 1 mole of O2 gets used to produce 2 moles of N2O. And then we know that 1 mole of O2 equals 32 grams of O2 because we already used that conversion factor up here, just flipped upside down. So when we multiply all this out, we end up with, let's see, 1.7857 divided by 2 times 32. So I got 28.572 grams of O2 used. So now that we know the amount of oxygen that got used up, we can round to correct sig figs. So we should round to the same number of sig figs as our theoretical yield here. So I'm going to round to 28.6 grams of O2, and this is the amount of oxygen that was used. So to figure out the amount that remains, we just need to subtract from our original amount of oxygen. We had 75 grams of oxygen to start out, so we'll do 75.0 grams minus the amount that was used, so 28.6 grams that was used. So 75 minus 28.6 gives us 46.4 grams, and we can keep that 1 decimal place because both values have 1 decimal place, so grams of O2, and this is in excess, so this is our amount of excess oxygen. And so that is the second part of our answer. We have 46.4 grams of excess oxygen.